I will make my speech in English. Why is that? Because yesterday I spoke in Greek, and Dr. Kata Berkesi didn't speak to me after that. So I will make the speech in English in order to for her to understand what I'm saying. Okay. What have we communicated with you up to now? First, we have a method according to which we can use magnetic nanoparticles covered by cyclodextrins with different inner diameter in order to select the cations of the seawater. And then, following magnetic selection, let's say, using magnetic fields, different magnetic fields for different cations based on the size and the quality of the magnetic nanoparticle to have the actual cations. This means the metals out of the seawater. Okay, this is a method of desalination, and this is what we propose. Then, what Nikos Stefanakis presented. He presented a method according to which you can form a system to have super high thermal power concentration in order to be able to use it either for water evaporation or for concentrated electric energy production. Both are useful. He didn't want to separate it, okay? He didn't want to split it up. Okay, then the question comes, where the energy and environment in ships Hristoforou comes. The answer will be in my presentation. The first reason is that we have a hell of a lot of islands where Navy is playing a significant role, and in these islands, allow me to discriminate them in two different categories. One category is the isolated islands. Those islands which suffer from central electric energy supply and also suffer from the absence of drinking of potable water. This is a significant problem. There, the electric energy is also a significant problem. Apart from that, there are also the other islands, the rather larger islands, even Creta, which has a hell of a lot of power stations, but based on petrol, electric energy generation method, and also with renewables and this stuff. All of us, if we have visited the islands of the Aegean Sea, we know that we don't have water enough there. We have experienced that. There is no reason between us to explain further. And the point is that these, and of course the Greek Navy plays games there. And then the question is, do we have weapons to fight against desalination in these areas? And I would say, I would add not only desalination, but also electric energy production methodologies. The answer is that we have weapons, and the weapons are three. The first is that in the periods where we need drinkable water and electric energy, this means summer, spring, summer, autumn, we have high winds, and also we have high solar energy on these islands. Yes? Second is that we have local technology. I write there that at the National TU of Athens, we have such technology. I don't mean only the NTUA, I also mean the other sources of technology in Greece. And we all of us know that the Greek Navy has significant know-how in several techniques, and from yesterday's presentations, the conclusion is that the Greek Navy is willing to collaborate with the universities in order to obtain such technologies. There is also another reason, you will see in my last slide, why the Greek Navy must be, not should be, but must be a partner in this project. Okay, let's start. Our proposal. Our proposal is the use of anchored platforms with single or multiple wind generators on their basis, on their platform. These platforms are equipped, apart from the electric energy harvesting devices, they are also equipped with desalination facilities, but also with energy storage facilities, generally speaking. And Stefanakis mentioned about that. The point is that sometimes we need the water, and at this point, at this time, we do not have the possibility of having energy. So the idea is to have a platform, an anchored platform in the sea, not destroying, let's say, the environmental conditions of the island, not destroying the touristic, activities and things like that, in order to be society-friendly solution. So this technology is well developed. At this moment, our group is collaborating with the Swedish company named DVI, Deepwater Wind Energy Invest AB, and with the Power China company, the electricity company of China, in order to develop these farms in Greece. But NTUA wishes to develop this technology just for the sake of desalination production for the isolated islands and the other islands in the Aegean Sea. And this is due to the high. This slide is not clear, actually. Sorry for that. This slide wishes to, but doesn't obtain, to show to you that the wind power during the summer months is quite strong in the Aegean Sea, and therefore we can use wind energy production for the energy developing purposes. Of course, we can and we will use the solar concentration methods for similar reasons. Why? Because this platform, we have proved already that this platform is quite stable in the Aegean Sea. Why is that? First, because it has, below the sea level, it has a hell of a lot of mass in order to store energy and in order to provide the desalinated water, making a heavy platform which can be really stable on the Aegean Sea. And the nature gave to the Aegean Sea a lot of wind, but very small waving. So this is another factor permitting such stable operation of the platform. Okay, energy storage. I'm not fan, and our team is not. We're not fan of the water energy storage methods. There is a simple reason. We are not mechanical engineers. We are electrical engineers and metallurgists. Therefore, we wish to develop techniques which are based on materials, and the materials we wish to use are batteries, and the batteries we wish to use are lead acid batteries. Why is that? Because they are cheap. Is there any other reason? Yes, because they are heavy. But is it an advantage? But of course, it makes more stabilized the upper platform of the desalination platform. Yeah, it makes it more robust, let's say, in the conditions of waving. Is it enough to use only batteries? Probably, if you want to use it for desalination purposes, yes, they are enough. But if you want to use your platform for dual use, this means for desalination water provision and also for electric energy supply to the isolated island, then apart from the battery, you must also you must also employ the use of supercapacitors. Personally, I don't like very much the solution of the fast cycle batteries. I prefer supercapacitors for a simple reason. They can last for a long time. They are expensive, yes, but we can make them. We can produce them. There is no need to pay overheads to foreign products in the moment that we can produce them in Greece. How can we do that? By collaborating with different departments of the National Technical University of Athens and also by the Greek Navy. Production, characterization, and experiments. Actual use for corrective actions. Okay, these are the two technologies we wish to use for energy storage purposes. So the question is lead-acid batteries so good in order to use them? I told you that they are heavy enough to provide a stable platform. But do they last for long? We all know that these lead-acid batteries, particularly in case of frequent charging and discharging purposes, suffer from lifetime, from lifespan, duration. We have faced. Okay, the reason for that is that these batteries suffer from several problems. Some problems are destructive. For example, a battery can crash with something and then it is destroyed. There is no way to repair it. But there are technologies according to which, okay, so for some cases, actually, I have stolen these presentations, these slides, these 2-3 slides from Dimitri Kosivakis' presentation in the next room, giving you the opportunity to see what you haven't seen in the next door. So there are certain cases that these batteries cannot really be used if something like these accidents happen. So, in case that we suffer not from this kind of accidents, but we suffer from sulfation of batteries, which is the actual problem in lead-acid batteries, then we have a technology to counteract on that. What I mean by that is that lead-acid batteries, as all batteries in the world, or all devices in the world, suffer from two kinds of things. First, from an accident which can be repaired, and from accident which cannot be repaired. If battery is crashed, there is no way to repair it, period. But normally, the lead-acid batteries do not suffer from that accident, from that kind of accident. Particularly, the platforms cannot suffer from that kind because it is quite rare to meet something stronger than them in the middle of the sea to be crashed with in order to have such problem. Usually, lead-acid batteries suffer from sulfation. What is that? Sulfation is the concentration of salts in the electrodes prohibiting the actual operation of the battery. Here I write that we can face it up. How? Dimitris next door presented a method according to which, in the parallel session, I mean, he presented a method according to which we can desulfate the batteries, promising high lifetime span. These days, we work on a method according to which we supply the battery, the destroyed, let's say, battery, with small sinusoidal signal in order to provide ionic discharging of the electrodes. This means that we select a particularly appropriate frequency for the electrode, self-specified by the circuit of the battery itself, in which we obtain the maximum possible oscillation of the cations of the salt on the surface of the battery, according to which we can remove the cation inside the solution. This way, we try to rejuvenate the battery. This approach can be characterized as unique. And this approach promises that, the rejuvenation will last for long. Why? Because we do not only heat the salts on the electrodes to put them down, to remove them down to the bottom of the battery, but we also reconstruct the actual electrolyte of the battery. Preliminary results in the laboratory indicate that this works well. We applied the method in the water company of Greece and in some houses, in some private houses, some houses in Attica, and we used obsolete batteries, and in 3 months' time, the batteries have been back in operation. So we are sure that this method promises things, and we invite you to the next occasion of ASRAE workshop, hopefully at the NTUA, in the library of NTUA, in order to discuss these new advantages in this environment and energy integrated cluster of ours. Okay. Up to this moment, I described what we have done. And I repeat that we have done 3 things. Desalination with powders, magnetic powders. Solar thermal concentration and promising techniques for long life span of lead-acid batteries. Where is the Navy involved? Apart from providing their facilities for testing our equipment, they can really be useful in controlling the operation of the stations. Remember that these stations are anchored, so it is pretty easy to remove their position. They are not very big. They are 20 by 20 meters wide, let's say, and at least up to 40 by 40 meters wide, and therefore a boat from the Greek Navy, I don't think that this particular boat will play the game, but another boat selected by the Navy can de-anchor the platform and move it to another place. Why is that? Because in summertime, we need these platforms in isolated islands where there is no drinkable water and no electricity, and they are remoted. They are not connected with the electric grid, but in winter time, the people remaining in these islands, they do not need such big system. We can easily provide them with storage energy systems, batteries, and providing them, low-cost energy and desalination systems. These systems can then be used in other areas, like larger islands. I'm not talking about Crete and Rhodes. I'm talking about the rest of the islands in the Aegean Sea. By the way, this technology can be well implemented also, the technology of desalination and energy storage in other islands and other applications of the Navy. Why is that? Because energy storage is always useful. And I do know that lead-acid batteries produced in Greece must extend their lifetime in order to reduce the maintenance and use and cost of use. I think this was my last slide. Yes, this was my last slide, and I am at your disposal to discuss with these technologies at your availability. Thank you very much for your attention.
Where do they belong to? And who does the security trust for you?
I answer question by question, I suppose.
Yes.
Okay. Security. These platforms are checked by the American Bureau of Shipping, are to be checked by the American Bureau of Shipping, providing the ability of their class. We do not really want to get involved in the security issues. We want just to follow their instructions for corrective actions of the platform. But the answer is that ABS is taking care of this.
Who?
ABS, American Bureau of Shipping, Αμερικανικός νεογνώμονας.
Νεογνώμονας. Who do you think would be guarding these facilities? Well, that's why the thought that asked who will own these platforms is related to who will govern.
What do you think?
I think that it's a hot potato that no one wants to hold.
Look, the guy who holds the hot potato takes advantage of the hot potato. Yes?
Yes, that's true.
How much does the Greek state, in the days of the crisis, pays for distilled water, for drinkable water for the islands? Do you know? Do you know the number?
Lots of money.
A little bit less than 1 billion euros for the last 10 years. Is that an answer? Is that an answer for giving the right to someone to guard, maintain, and provide the water to the islands in the half of the cost? So, but my answer is not to give it to the private company. My answer is that the collaboration of different state members will provide inexpensive water and electric energy to these people, period.
I have a question.
Yeah.
And taking the opportunity from your answer. My question was, okay, the benefits are obvious for me. And I totally agree with you that the state should do something for this type of islands, maybe a PPP or state δημόσιος τομέας or something else. You didn't tell us about the cost, but you said in your last answer that it's half of a billion. You said that we pay €1 billion to take drinkable water to these islands. So, what's the cost? For 10 years, yes. So, what's the cost of these platforms? And an estimated budget, I mean. And what is the life cycle of such facility? For example, if I made a platform, it will last for 5, 10, 12, 40 years?
I understood the question for the first moment. I don't interrupt you because I'm thinking, calculating the numbers.
Okay.
The platform with a single wind generator providing 3 megawatts instant power, or let's say you make the calculation for the conversion to watt hours, together with batteries and a commercially available, not our technology, a commercially available technology, is in the order of 10 to 11 million euros. And this can support a number of islands in a vicinity with the help of Navy, or simply with the help of plastic tubes, you know, bringing the water to the island, where the cost at this moment is over 30 to 35 million for this area of islands. I'm talking about the islands of Dodekanica.
Per year or per?
This is per year. And concerning that the lifetime of such platform is in the order of 25 years, as usually such a system is, you can understand how cheap at the end of the day it is.
The problem is that, right now there is a big crisis, so probably you have made some effort. Okay, we all know that nowadays there is a crisis in Greece, and we know that the universities of Greece made a very nice job in the research sector. Many of the universities have tried to find investments and investors in order to produce their technology. Do you have any
idea how to overcome the problem of the cost?
Yeah.
How to overcome the problem of the cost? Yes, I have an idea. And today it is the first time. It is the first time that I am announcing this proposal, this offer. There is a certain interest from foreign investors to develop such platforms for just electric energy production, connected with the mainland grid. This company is Power China. And Power China is offering the lateral production of the platforms if they are allowed to build their farms in the areas they want, in the areas that they have been permitted.
This is the first time, my people, Dimitri Chosivakis knows that, this is the first time I say that in public. That, okay, we know that this is a cost. You know, you people from the Greek Navy know about the Alpha Omega, yeah? The benefits. So this is something like that. These people want to produce energy in Greece, offering their
money.
Offering their money and offering the advantages described by the Greek law. Additionally to that, they agree to make this contribution, to offer to the Greek islands, particularly to the isolated islands, these platforms. And this is a good forum to bring this information to the state, to make things fast and inexpensive.
Sorry for that. Have you considered, instead of using wind turbines, to use tidal turbines, because they're kind of becoming more and more popular the last decade? And is there any field that they're applicable in a GNC or not?
Okay. Do you want my fake answer or my honest answer?
Yeah.
I will give both.
I need your honest answer, because I'm quite familiar with tidal turbines. It was my essays and my thesis on that,
Okay.
so I'm more than familiar with
Okay.
that. I'm not sure if we have the potential in the GNC.
Okay, the honest answer. The honest answer is that tidal energy is more useful, after my opinion, more useful than wind energy. Why is that? Why is that? Because it is permanent.
Exactly.
It is permanent. The problem is that Chinese people pay for the wind energy.
Yeah, I got the answer. Okay, then.
Okay, in this way, I avoided to speak about.
Anything else? Yeah.
Do we have time for
Yes.
We have time.
You know that I am disposal for you and for all Greek Navy people after the conference also.
Yeah.
My question is that is another project, this platform, the small islands, another project, this connected to the grid. There are two different projects. So we are talking different terms. Is that right, or is it one project that is split into two phases?
If you calculate here, we talk about 24 wind generators.
Yeah.
We talk about 72 megawatts. Where the hell can we use them for the isolated islands? We talk about only. I understand that I can agree with you. These are two different. Actually, there are three different projects on that. One is the energy production. Anchored platforms for energy production. Is it important? Yes. Why? Because they give back not the 3% of the money required by the law, but they give back 6%. This is an offer. Second is desalination of water in the areas of the equator. And I practically mean the areas of the Gulf countries. Why? Because they have money. There is another issue now. How can we use techniques to provide drinkable water in these isolated islands in order to be allowed, in order that we are allowed for bringing there our children to make summer holidays? This is another question. And this question has been answered by the platform, which can be there from, let's say, April, May, till early autumn, and then be brought back to a more crowded island wherever it is useful to be. So yes, we talk about several projects, and the desalination project is, after my opinion, based on either 1 or 3 wind generators only. This means only between 3.6 up to 10.8 megawatts power production. This amount is actually useful for both delivering potable water, but also delivering electricity to the isolated island.
Yes. I understand.
Are there any other questions? No. Okay. Thank you very much, Professor. It was a very, very nice workshop. Thank you all.